Hi, Robert. I'm Ross, and I hope I can help you with your MVT problem here. The mean value theorem can be pretty tricky, so I'm going to do my best to explain what it means, give you an example, and then apply that to your problem. So down here at the bottom right, the MVT says that if f is continuous and differentiable, we'll come back to those words, on the interval a to b, then there exists c, which is just any number, such that f prime of c equals f of b minus f of a, over b minus a. So that's a lot. To simplify that, what I generally tell people is to think about it this way. First of all, f prime of c is an instantaneous slope, which is the slope of a tangent line. So you got to keep those in mind. We're talking there about the slope of a tangent line. And f of b minus f of a over b minus a, that's just the slope formula, which is going to give you an average slope on that interval. And that's also the slope of a secant line. So what the MVT is really saying is that if you pick an interval, they're saying a to b, yours is going to be 0 to 2. So on that interval, whatever the average slope is, you should have a point where the instantaneous slope is also is equal to the average slope. So you need a point where the instantaneous slope is equal to the average slope, where the slope of the tangent line is equal to the slope of a secant line. And I'll show you what that looks like down here in my graph. Keep in mind, I glossed over these first couple words. The function must be continuous and differentiable for this to apply. And I'll tell you my graph that I drew here, those are true. It is continuous and differentiable on this interval. So let me show you what this would look like. I set up my interval here from a to b, and to calculate the average slope on that interval, we could use a slope formula. In this case, I don't know what the y values are, but on purpose, I set this up so that we would end up with a horizontal, let me get that through there, a horizontal tangent line. So if you use the slope formula, I intended for us to end up with an average slope. I'm going to put m average of 0. So back to the MVT. As soon as we find that 0, what that means is that on this same interval from a to b, there should be somewhere where the tangent line also has a slope of 0. And hopefully you can see that that is the case. In this problem, that would happen. That's a poorly drawn line, used the wrong tool. That would happen right there. At that point, in fact, I intentionally made that c. The slope of the tangent line also is 0. So that confirms the MVT here. We found at least one point, there could be more, but we found one point that happens to be C on our interval where the slope of the tangent line, the instantaneous slope, is equal to the slope of our secant line, which is the average slope. So now let's bring that up to your graph, which I've already drawn here based on the equation you gave. They are intentionally pointing out, right? So your interval is 0 to 2. They are intentionally pointing out and making you notice that the y values there are zeros, right? So they are level, just like mine were over here in my made-up graph. And they're pointing that out to make it super obvious that your average slope is gonna be 0. You could work out the slope formula there between those 2 points if you wanted, but the average slope is gonna be 0 just like mine was a second ago. So what does that mean? That means that according to the MVT, if everything's true, we should end up, just like we did over here, with a tangent line equal to 0 at some point. So between 0 and 2, somewhere between those green lines, we should have a point where this tangent line is equal to 0. And you may be thinking, oh yeah, we do, Ross. That point, just like over on your graph, that point is going to be right there, right? Where that corner of the V hits. The problem with that is that that point on your graph at x equals 1 does not technically have a slope. Anytime, sometimes that's called a cusp, right? Or sometimes people just call it a sharp point. Anytime that happens, the function does not have a slope at that point. You cannot have an instantaneous slope at that point. And that's because the limit coming from one side and the limit coming from the other side of the rate of change are not are not the same. So what that means is your graph, in this case, the problem from the very beginning is those two words I read, continuous and differentiable. So let's go back to that. Your graph is definitely continuous because there are no discontinuities anywhere on that interval. There's no jumps, there's no holes, no breaks, nothing. So it is continuous, but it is not differentiable. The word differentiable means basically you can take a derivative anywhere on your interval. And if you can take a derivative, you can get a slope. Like I just said a second ago, you can't get a slope here at x equals 1, which means the function is not differentiable there. So the reason for your problem that this value doesn't exist is because the function is not differentiable on your interval. And that automatically means that the MVT, the mean value theorem, doesn't apply. Now on part B, what they're trying to get you to really understand is, without saying it, they're trying to get you to say, well, wait a second. My average slope was 0, so there must be a place where my tangent line is 0. So what's wrong, right? Why can't I find a place where my tangent line slope is 0? And the answer to that is, calm yourselves down, right? We're not contradicting the mean value theorem because the function is not differentiable to begin with. You can think of those two words as kind of like keys to unlock the mean value theorem door. If you're going to use this theorem, your function has to be continuous and differentiable. And if either of those don't apply, you can't use the theorem and you can't apply it. So I hope that helps not only to answer your question, but also to help you kind of understand how the mean value theorem applies to different types of problems, what kind of differentiability means and continuity, and how all those things work together. And good luck with further MVT problems.